What's going on, everybody? This is problem number 11 on the Basic Skills Review Day 1 worksheet for Integrated Math 2. The question is asking, given these 3 points, if I connect them, does it make a right triangle? And I'm supposed to justify my answer algebraically, meaning I'm supposed to show either with slopes or distances that this is a right triangle or not. So what I can do to justify this or work this through is to try to come up with a solution. If I have for a right triangle, remember, right triangle means that 2 lines cross in a perpendicular fashion. So if a slope, as an example, this is a sample, if the slope of one line, let's say the slope of line EF, may be how I would write that, is equal to 5/6. If I have another slope, maybe the slope of, let's call it FG, is equal to 6/5, and it's the opposite sign, negative, then these two are perpendicular. Perpendicular slopes are negative reciprocals of each other. So remember, M stands for slope. So I'm going to use slopes in this picture to try to figure out if the rise and the run for any of these points, this rise and this run, or this rise and this run, if any of these are related in a perpendicular fashion. So let's just go ahead and write that right here. Let's start with the slope from A to B. So if I look at the slope from A to B, the slope here is a -1 rise, and if I count 1, 2, 3, 4, 5, 6, 7, -1 over +7 for the slope of A to B. Slope triangle, -1, +7. I could also show that by using a change in the y values over a change in the x values. Remember, that little triangle means delta, which means change, which means subtract. So if I take the y values and I say, how far is it from 1 to 0, and I find the difference in those, and then I do the same thing with my change in x values, how far is it from -5, difference, to +2, what you'll see mathematically is 1 minus 0 is 1, -5 minus 2 is -7. I end up with the same number. So that's the slope from A to B, the slope of this line right here. So now if I want to find, let's say, the slope from B to C, I can take the difference in the y values, 0 minus 3 over 2, the x values, 2 minus a -2. Remember, minus a negative makes it a positive. So this is -3, 0 minus 3, over +4. Or I could count. What is the rise? 1, 2, 3. And then backwards, 1, 2, 3, 4, -4. So if I compare those two slopes, -3/4, 1/7, those are not inverse or opposite negative reciprocals of each other. So the final piece of the puzzle is to try to find the slope from A to C. That's this line right here, slope of that line. Well, the slope would be the change in y values, 1 minus 3, over a change in x values, -5. And I use the -5 first because I use the 1 for the y value first. If I use the y value of this point first in my equation, then I have to use the corresponding x value as well. -5 minus -2, simplify. 1 minus 3, that's -2. -5, two negatives make a positive, right, is going to give me a -3. So -5 plus 2 is a -3. Two negatives make a positive when you're dividing. So that slope is a positive 2/3. Visually, if you look at A to C, it is a increasing slope versus decreasing and decreasing. Increasing slopes are positive, decreasing slopes are negative. None of these are negative reciprocals of each other. So my conclusion is that means, therefore, triangle ABC is not a right triangle. -1/7 is not perpendicular to -3/4, which is not perpendicular to 2/3. That's how I show algebraically using slopes that triangle is not a right triangle.